First hour and 15 minutes or so, I'm going to give you kind of the Seg3D user version. So everything you need to know about using Seg3D as someone who just wants to segment things. And then about 1:30 or so, I will be done. And we might take a short break, and then I will hand it over to Jeroen, who's going to go through more of a developer level view of things. So Jeroen is going to show the architecture, kind of how the code is organized. So if you want to add a new module, a new filter, whatever, he will be the guy who will walk us through that. He'll show code and things like that, and he will go until we pull him off stage, I'm guessing. So he'll start at about 1:45, and I guess we have the room till 3:30. Any other details you want me to share? Great. So one other logistical thing for myself and certainly for Jeroen is we'll just keep talking. This will be better for you, more useful for you if you stop us and ask questions. Otherwise, we'll give you sort of our view of Seg3D and how it's useful to us, which isn't really what you guys want. You want to know how to be useful for you. So please ask questions. Okay, so thanks for having us today. I hope this will be useful for everyone. Seg3D, I'm going to give you just a quick little bit of the history of it and then jump into the overview. So Seg3D version 1, everything from 1.0 through I think 1.12 maybe was the last version, was developed here as part of the NCR-funded CIBC Center. And it looked something like this. So this is actually a screenshot from it. And it was great. It was useful. It had sort of this 4-panel view and a bunch of different layers that you can manage. These are different label maps over here on the right-hand side and tools over on the left. And so conceptually, it was great. There were a couple of missteps probably in terms of the design. Some of it was just a timing thing. So Qt was not out there, was not easy for people to use yet, and so we kind of built our own user interface thing, which with hindsight was a lot of time spent on something that eventually we threw away. And it was a little bit kludgy to use, partially because of that, but the concepts were good. Specifically this idea of it's kind of a 3D version of Photoshop, and we have the layers over here and let people manage those. And so in 2009, all of this Recovery Act money came about. So this was the Obama administration saying we need to get the economy back on its feet. And so the Recovery Act funds, and I apologize to the people who are here for the talk that we gave last month. These next few slides will be repeat, but just wanted to give everybody context. So the Recovery Act money came to NIH, down to the various centers. People had to apply for it. And what the SCIInstitute CIBC Center applied for was a 2-year project to go in and work on sort of a new and improved version of Seg3D, this Biomesh 3D thing, ShapeWorks client. We were here talking about these things a month ago, and Liz has notes from that, and I can't remember if you guys videotaped it. But today we're going to talk about Seg3D. So the idea behind this project was to go in and harden the code. There were certainly issues with crashing. People were having a hard time compiling it. We wanted to make it easier to use. So again, the concepts were good in the first version of Seg3D, but needed to be a little bit easier for people to get into. And so, adding professional level things like, oh, there's a preferences panel, and we have reasonable defaults and installers, and all those good things. Right, again, with professional. So, improved look and feel. We are using Qt now, so you'll see that there are these dockable components that you can move around everywhere. We've put in tooltips, again, to make it a little bit easier to use. There's a nice reporting feature built in so that when there are errors, when things are going to take a long time to run, you get reporting, you get progress meters move across. We have things like auto-update, auto-save are being built into these. And really the thing that we had pitched in this error proposal was a provenance engine, specifically for Seg3D, so that we could keep track of what was done to produce this beautiful result at the end, so that A, you could sort of remember, 2 months later when you needed to go and run it again. B, you could share it with colleagues. C, you would be able to rerun the same sort of provenance trail on other data sets. And I'll skip over the client-server workflows. That was really more for the other applications. Okay, so so the next hour or so, I'm going to run through a bunch of demos showing you different features in Seg3D, how to get started in it, how to load in data sets, how to segment them, all that good stuff. But first, you need to download and install it. So it's all hanging off the SCIInstitute software page. So if you go to the software page and scroll down just a little bit, there's Seg3D. You can download it. When you get to the download page, it looks something like this. Depending on what platform you're on, you would download one of these. You can download it for source. If you're using Linux, you have to download it from source. But the version for OS X, the version for Windows, just has a nice, easy-to-use installer built into it. So the version that I'm going to be showing you is version 2.1.2, and it's this one. Okay, so some demos. So let me drop out of here. Who knows how this is going to work, Shem? So I'm going to try and launch a demo. We'll see how it goes. Okay, actually, let me start this from scratch. So when you fire up Seg3D, the very first time, so is that coming through okay for you? Mm-hmm. Great. Okay, so the very first time that you launch it, it's going to ask some questions like, where do you want your projects to be installed? So Seg3D wants to have a directory where it's going to keep all of your, all the projects that you're working on, and then it can keep track of it. So, so it'll just ask you where that is, and then after that, when you start it up, it always looks like this. So this has a list of recent projects, things you've been working on, and then you can select any of those and open them. You can also open projects from other places, from this open existing projects, or start a new project. So, so there's two concepts that you'll hear us talking about over and over again. This concept of a project and a concept of a session. And so a project is really, I need to go in and segment this tooth data set. A collaborator gave me this tooth, I need to segment it. As I'm going through and segmenting it, I may try a few different strategies. I tried this, it worked out okay, then I tried this other thing. You can save those results as separate sessions. So they point to the same data set, but they're different workflows, if you will. Okay, so I'm going to launch one of these. It's very confusing for me having two desktops. So I'm going to launch the tooth because for the algorithms and filters that I want to run, they will run faster on the tooth. And actually, I have to grab one thing from that. Okay, so so I mentioned that this is a Qt application. So this view that, let's see, I don't need this up here anymore, do I, Shems?
Nope.
This will be a little bit easier for me if I get this out of the way. Okay, so so we have several panels here. Over here on the left, we have our tools and filters panel. We have our main kind of rendering window here, and we have our layer manager on the right. So so the concept is hopefully somewhat familiar to people. That over here we're going to be managing all of our data sets and all of our derived layers. So if I load in a data set, grayscale imaging data, and I do some things to it, I will be creating intermediate representations over here. Those will populate the layer manager. Over here, I have a list of tools. So I'll start running some examples of these, but for example, if I wanted to run a threshold tool, it will show up over there. So tools, tools, threshold, Great. So here's my threshold tool with all of its controls associated with it. When I'm done with it, I can close it or I can leave it here running, but I'm going to close it for now. Okay, so all of your tools show up here, and then in the middle we have different rendering views of our data set. So this is configurable. Over in your views panel, you can say that you want a, this is a what we call a 1 in 3 view. Here's a 2 in 2 view. Here is a only one viewer view. So you get the idea. These are flexible and configurable. And inside of here, so I'll talk about navigation and just how you control this in a second, but what we're seeing is a coronal slice, so a Y plane slice in the big window, and then we're showing a few other slices over here in these, an axial, a coronal, and a sagittal. So I have two different coronal slices, and those show up as two different green lines, right? So my active one, this big one right here, is being, this one is showing up as that thick green line, but you can see that I have more than one. So if I go in and move this one, they move differently. So associated with each of these windows here, we have a set of controls. So I can control, I'm going to switch this one into volume view. So this tab that, or this little button here that's showing you which one we're seeing is also a controller. So I can switch over to, for example, volume view. And now I can go in and turn on and off the visibility of the different panels. So I have fog on, which is why things are looking a little bit dim at the bottom there. I'll show you how to turn that off in a second. Okay, so for each of these, I can turn on and off whether it shows up in the main viewer. And I'm just going to quickly run through these separate controls just so you know what you can do. So this one, so we have the ability to pick in these views. So if I, maybe it's shift. Nope. Sorry, I've already forgotten my mouse controls for this. Alt. So if you pick in here, no. Alt. Right mouse. Well, this would be a great time for me to show you the help menu. So up in the help menu, you can pull down keyboard shortcuts, and that pulls up this window that shows you what some of the controls are for navigating and moving around within the different windows. So some of them are not context sensitive. So things like saving a project, saving a session, and then some of them are going to be for your active tool. So so I had the threshold tool open a second ago. That's what that's showing. Anyways, Yurin will figure out for me what button I'm. Command right click. Thank you. So if I click around in this view, it snaps the other views to go to the position that I'm seeing there. So this is just kind of a picking thing. This over here just toggles on and off whether I have grid lines. So these are useful for just kind of getting sense of scale. This is going to flip the data horizontally, flip the data vertically. This is turning on and off all of the overlay elements. This is turning on and off the line. So we tried not to clutter it up too much with too many different features in here, but these seem to be the ones that people wanted access to the most often, so there they are. Okay, this lock thing is perhaps worth noting. So if I switch this to be another axial view, so here I have my two blue axial views. If I move one of them, and here I'm just using the scroll bar on my mouse, if I move one of them, it can move independently of the other. If I go in and tell this view and this view to remain locked, now as I move through in one of them, the other one is staying at a fixed offset from it. So hopefully that's clear. Turn those off. And this is, you do have complete control to zoom in. So shift right mouse is zooming, and if you get lost, you can always just auto view back in. That's what this is showing. Okay, so so those were all of the controls for the slice view window. Looking over here at the volume view window, you have a few different options that show up. So This one snaps to the closest axis. So if you're trying to set yourself up so you're looking exactly down the y-axis, as long as you just get close, this will snap you to that view. This is going to turn on and off lighting. So if I rotate, now I don't have any lighting cues set up on these planes. Here's turned on again. This is the depth queuing. This is the fog thing that I was talking about before. We have support for clipping planes. We have support for ISO surfaces. I'll show you these once we set up some label maps in a second, showing the slice plane. So it just kind of goes on and on. Again, we tried not to have too many things in here, just the things that people had asked us for. And those are the controls that are exposed. There are some more complicated controls that are associated with things like volume rendering. So let's take a look at that. So up here is a list of which panels are currently active and available. So I have my, the project window is this tab down here. This is what I was talking about before in terms of projects and sessions. So for my current project, it's saved out these sessions. It's doing autosave to save those. So in case things crash or in case you screw things up, you can go back to an autosave version. For all of these, you can go back to a previous point in time. So it's saving all the information necessary to go back to any of these versions. And these are just project notes over here, so you don't have to fill that out. We also have the tools and filters. I showed you the threshold thing briefly. But there's two windows that aren't showing up. So the volume view window puts itself down here. So so for the volume view, there's three things that we can control from here. So this is the fog that we saw a second ago. So if I turn this back on, this is controlling how dense the fog is. These are your clipping planes. So you can enable them one plane at a time. And then this is controlling whether those are being used. One of these down here, clipping, right. And for each one, you can control the orientation of the plane. It's basically a 4-parameter plane. And then the last one down here is the volume rendering. So for volume rendering, you have to tell it which input layer it's using. So we tell it to use the tooth. And here's a transfer function that it has. And now it's doing volume rendering of that tooth. So I can turn on and off the slices in here somewhere. I think it's this one. And then for the transfer function, this is just a one-dimensional transfer function, but you can put in multiple features, and each one has its own color and its own settings for ambient, specular, shininess, all of those types of things. And it's overlaid on a histogram. I think everybody has seen volume renderers that look kind of like this. This is your sampling rate. The other thing that's in here, this won't be a great example to show it off, is we do have ambient occlusion built in. So here you're getting some shadow type cues coming out of the volume renderer, and it's all being done in hardware. So that's the volume renderer support, and then you can of course turn the volume renderer piece on and off. So so I'm going to keep going with lots more stuff. But any questions so far about sort of the viewer components of the system? Nope. That all makes sense. Okay. And it's doing bricking for the volume rendering, so it can handle pretty big data sets. Seg3D itself does not support out of core rendering, so you're sort of limited by the amount of RAM that you have. Okay.
What's the fundamental kind of conceptual difference between this and slicer?
There's underneath them, they're doing many similar things. So we didn't rewrite all of our own filters. Our things are ITK based, just like their things are ITK based. I've only used Slicer a little bit, but it seemed like it had become a very large, complex tool. It was very much focused on neuroscience applications, which if you're doing neuroscience applications might be just fine. We wanted something that was a little bit easier to use for general types of applications, and we like this this way of sort of viewing in 3 dimensions and ideally having filters that were going to be, all running in 3 dimensions. And so underneath it all, kind of at the mid-level, the architecture is different, and Jeroen's going to go into details about sort of how the tools and the actions all work together and the Python scripting and whatnot. At a high level, they obviously have some similarities. You're loading in volumetric data sets. You're running different ITK filters to segment them. And the directions that we're heading with the software are different. So I'll cover some things at the end, which are kind of future work. But at the beginning of a project, both of them are going to look like segmentation tools, and they're going to have more similarities than they have differences. Is there anything else that I should add for kind of how is this different?
Yeah, I think also we can. One question is to some extent it's not different. So to some extent it is, and to some extent it's similar. So I think to understand that, it's worth just sort of kind of considering the history a little bit. So 5 years ago, when we really started digging into this, Slicer was not anything that was adequate for open source or joint development or whatever. Now, over the years, Slicer through the NAMIC project has gotten somewhat better in terms of its ability to be maintained by a group, but this was from the beginning designed to address some of those, to stress some of those issues, right? So that was one thing. The other thing is that Slicer has definitely kind of adopted sort of this expansive view of its capabilities. It has to do this and that and so forth, and it's adopted a pretty heavyweight plug-in infrastructure, which in principle makes it easy to put things in. But I think the architectural issues about how that's actually going to play out in the long run. So there's kind of some different, different design trade-offs that have been made with this tool, but in some sense they overlap in terms of their uses considerably. And they're developed, you could argue, in terms of the open source aspects, not open source, but truly sort of, open development aspects of this were developed jointly with Slicer. Slicer in some form has been around a long time, but the recent form of Slicer, which is appropriate for NAMIC, was kind of done jointly.
Because it's, the concept of slicing and
almost any 3D tool is going to have a similar view. So, and I guess I should also say is there's been, I would argue, some sort of synergies back and forth between these 2 efforts. Like there's some ideas that were originally in this, like this whole notion of how to use these layers and manage them, and the fact that it was going to be a Photoshop-like thing, which only came into Slicer after, I would argue, after they saw that stuff in here. And and likewise, I'm seeing things in here that look to me like the first time I had ever seen it before was in Slicer. So I think there's definitely some cross-fertilization that's going on between these 2 groups.
Yep.
So it's not like a fundamental conceptual
I don't think so.
difference between
No.
how you see the 3-dimensional worldview.
Quite to the contrary, we're both using ITK underneath, right? So to some extent, we have to have more in common than we have, different. We weren't going to rewrite all of our own filters. ITK is great. We just wanted a different interface to it.
Dave, can you hear me?
Yep.
So we couldn't hear any of that exchange, so a summary would be helpful.
The question was, what's the difference between this and Slicer? And Sarang and Ross were mostly talking about it, but the summary, I guess, is that yes, they have lots in common. They're both loading in 3D volumes and processing the 3D volumes, and they're both built on top of ITK for a lot of the underlying algorithms. But from a user interface level, they're different. And what Ross pointed out is that if you look at kind of the developmental history of it, Slicer today is not the Slicer that was there 5 years ago when we got started with this project. So these 2 systems have co-evolved in a sense. There are features, user interface kind of aspects to Slicer that were probably inspired by some of what we had done here, and vice versa. So I think there's kind of a healthy coexistence that's going on there. Okay, one thing that I wanted to show, I mentioned it before, is that there is this preferences panel. So just so you have a sense of where the controls are when you start using this software. A lot of things that you would want to turn on or off or tweak or whatever are going to be here in the preferences. Things like auto-saving, this sort of smart auto-save mode where it will kind of wait till you're not doing anything and then save. It's doing file compression, so these files for the most part are nerds when they're living on disk. And so there's different levels of gzip compression, things for saving out DICOMs. This undo redo buffer is important. So once I start running some of these filters, you'll see this in action, but it is keeping a provenance history, and you do have the ability to sort of undo things that you did. But you have to tell it how much memory you want to make available to this, because storing a complete version of everything that you've done is going to get expensive, and so it's going to start throwing away the older stuff if it runs out of space.
Which DICOM library do you guys use? Is it DICOM TK?
Are we linked against GDCM?
We do GDCM 2.0 and we have as well ITKs, GDCM as well, but mostly just GDCM 2.0.
Okay.
With some tweaks to make all the files work.
So you handle full DICOM
Yeah.
export?
Yeah.
Yes. Right, so the question was about DICOM and which DICOM library, and you pointed out that we're using GDCM 2.0, and we're also using ITK's GDCM, and yes, we support full export. Okay, this is setting up just sort of some of the defaults for how the views come up, whether you have zero-based slice indices. These are all just kind of minor conveniences, but people want them. Layer stuff, sidebars, so you can control which of the what things are preloaded in this tool. So you use the threshold tool every single time that you log in and use this. Go ahead and pre-populate it so that it's always there every time that you start up the tool. And which of the viewers there. Okay, and the last one is the provenance viewer. I'll show that once I've actually done some things to some data layers so that you can see what that looks like. Okay, so so back to our favorite tooth data set. I'm gonna switch back to the layer manager. Okay, so so one of the things that I wanted to show you with the tooth, just as an example, is measurements. So up here under tools, we have a measurement tool. And with the measurement tool, getting clipped a little bit, you can simply drop points and measure the distance between features in your data set. Every time that you do that, it's going to make a new measurement entry over here on the left. So I can go in and just keep making measurements of things. I can switch to different slices, measure things in those slices. You can measure across slices. For each of your measurements, you can go in and change its name for sort of what's showing up in the graphical view. You can change its color. We can go, this is listing all of the measurements. If I click on active measurement, you saw that M1 was the active one. So if I go to M1, I can add some comments about it. I can change its length. So if I go in and change it to be 4 instead of 6.24, it's going to actually shorten the measurement. So it keeps the first point fixed and moves the second point. Go to first point, go to second point. If you're in a different slice from where these measurements were made, visually they show up different. So here, let me switch this one to axial view so we can see them a little bit better. So they show up slightly dim until you're on the same slice as them, and then when you're in the same slice, they get a little bit brighter. And we only have support for distance measurements at this point in the system. We don't do angle measurements, right?
No.
Not yet. Okay. So that's the that's the measurement tool. You can control whether it's being reported in pixels, number of pixels versus actual. If we go over here and look at the data set, so this is my tooth data set again. This is the information associated with it. This is the spacing information. So that's why, because these are not just 1, 1, 1, that's why you have a difference between your pixel length and your actual length. Other things worth noting in here, we are keeping track of the origin and spacing information. So we support transforms. Data sets can come in translated with different spacing, and you can see both of them at the same time. That all works just fine. Okay.
Do you support arbitrary plane of measurement?
I'm sorry?
Do you support arbitrary plane of measurement?
Yes, we can, well, no. So you can measure between 2 points in different slices, but we don't have the ability to create an oblique plane, I don't think, no. So it's kind of up to you to get the plane right. We do have support for transforming data sets. And I'll show that to you in a second, which is somewhat related, but I realize different from what you were asking for. Okay, so I'm going to close the measurements for now. Okay, so let's actually do some segmentation with this tool. So the first thing that we're going to do is use the threshold tool and do some segmentation. So once I open up the threshold tool, my right mouse controls, overlaid on this histogram of the data values, controls kind of the upper limit. Sorry. So for thresholding, we're actually selecting a range of data values. We're not just selecting a single threshold and then everything bigger than that is lighting up. You can do that, but that's the equivalent of moving this this bar to the right. So you can select them up here or down here in this view. And I'm just going to set this one to right here. Okay, so there's my threshold. What you're seeing over here is just a preview of the segmentation. You can turn that on and off. You can change the opacity of your preview. When you're happy with it, you can create a threshold layer. So now I've created a mask, and it got added to my layer manager up there. So in this tooth data set, we have some holes. This is where the pulp is. So we can go in and run our hole filling filter. Let's see, mask filters, fill holes, and it launches another tool. So it's worth noting, in our tool manager over here, the threshold tool didn't go away. It just kind of got compressed, and I can re-expand it back if I want to go look at it. So they live there until you close them with the little close button. Okay, so so I'm going to choose this is my input layer. You can either run it using seeds or without them. I'm not going to put any seed points. I'm just going to run the filter, and now it's done. So if I turn off the orange layer, now those holes have been filled in. Okay, so if I look at the data set, I might have actually filled in a little bit too much because my threshold probably wasn't quite what I wanted it to be. So I can come back here to my threshold layer and easily change my threshold to be just a little bit higher, rerun it, and then go back to my fill holes layer and tell it to use this new version as the input. You always have the ability of using the active layer, and that way you don't have to drag and drop things over. If you turn that off, you need to specify which layer to use up here. You can always pick them from the drop-down menu, or you can shift-click on a layer. So here I'm shift, selecting this, and you can always just drag them on top to select which one you want to run. And I run fill holes, and I like that one better. I can go through and delete layers that I didn't like. So I'm going to delete the orange and green. If you press the minus button here, you can tell it which ones you want to delete, and then delete those layers. Okay, so if we wanted to look at a 3D view of these, we can bring in the volume view. I'm going to turn off fog to make it a little bit clearer. All you're seeing at this point is the slices because we haven't generated the isosurfaces, but we can do that right here. So now it generated the isosurface, and that's what I'm seeing. You can turn on and off the visibility of individual isosurfaces. You can generate new isosurfaces. So that's how all of that is controlled. With the isosurface generation, you actually have some controls for it. So down here is the isosurface quality. So this is going to downsample your input before generating isosurfaces. So if I tell it that I just want 0.25 isosurface quality, it will downsample an XYZ by a factor of 4, and then generate the isosurfaces. So obviously it goes faster. You're losing some of your quality. And then enable isosurface capping. If you have a feature that goes off of the side of your volume, there's always a question of whether you want to leave it open or fill it in, and that's what that control is there for. Okay.
The holes are 3D holes, not 2D.
Right, so it's, are you talking about the fill holes filter?
Yeah.
Yes, it's filling in 3D. It's finding holes in 3D and filling them in. That's correct. Okay, so so I'm going to load in another data set now. This other data set also happens to be a tooth. So with this tooth data set, I'm going to turn off these for a moment. Okay, so if you want to load in an additional, everything is referred to as layers in here, again, because of sort of the Photoshop nomenclature. So we're importing layer from a single file as opposed to importing it from an image series like a DICOM or a collection of pings. If it's already a volume, you do this one. And I'm going to load in tooth moved. So when you do an import, it doesn't know if you're importing a label map or if you're inputting grayscale data. It actually quickly scans the data and guesses which one it is. So if you just hit import, you usually get the right thing. But if you wanted to tell it, no, that was actually meant to be a label map and I had 8,000 labels, you can tell it that. And you can control whether, if you have a label map, or if you have a data set that's stored on disk that has values in it like 1, 2, 4, 8, it may be that each of those bit lanes corresponds to a material, right? In which case you would use this option, and it would load it in that way and populate several different layers. You can also just tell it that each unique value corresponds to a different layer, and it'll import it this way, or you can just say no, it's just a single mask. Okay, so so we're importing this other tooth data set, and I'm going to show them overlaid. So let me make sure I have the, what is this? I'm going to control the opacity of this one. So I'm dropping the opacity of that first layer to 0.5. And what you're seeing now are the two data sets overlaid. What's obviously they're not registered here. They haven't been registered yet. I'm going to show you how we go about registering data sets. Whoops. Okay, so so I already created a segmentation of the first one, and I have my my hole filled version of it. I'm going to go through and do that for the second data set. So selecting tooth moved, go over here again, choosing my same threshold tool. I'm just going to tell it yes, always use the active layer. I still have my same settings for what my min and max were, so that's convenient. I create my threshold layer, so there's that mask. I go into fill holes. I have to tell it to use this one, and I run the filter. Great. So now I have a hole filled version of that data set. And as we can see as I scroll through them, I'm not sure why I'm not seeing the other one.
You didn't have the active layer option clicked when you ran it, so the wrong layer.
Oh, I did the wrong layer. Thank you. Great. So let me go back to this one. Oh, yeah. Run filter. Great, that's better. So I'll get rid of the green one. Okay, so so now I have my yellow and red isosurfaces or label maps, and what I want to do now is run registration. So there's only 2 registration methods built into here. One is a manual one where you can apply a transform to a data set, and you have to specify the transform. The other one is an iterative closest point algorithm. And so I think that's under what's that?
It's points at
Oh, points at registration. Thank you. Okay, so this is one of them. That's going to be my target layer. For the other one, I'm going to use the other fill holes, the tooth. And now I get to specify how many iterations of iterative closest point to run, and then it's going to tell me at the end what it came up with as the values. So, so there, it's done running. And if I turn off the red one, the green and yellow, well, now I'm not sure why any guesses?
How are you running it to the closest point on a volume?
It's grabbing the isosurface.
Okay, thank
Yeah,
you.
sorry. Right, so I didn't connect the dots for you there. So, so it, I wonder if it actually generated the isosurface. Well, it must have. So usually this works. I'm not actually sure why it didn't work this time, why we're seeing these holes in it. Oh, I selected the wrong one as the current one. Fill holes. Okay, well, it doesn't have green stuff anymore.
Is there any kind of ransack? Is there any ransacking? Or how do you select your isosurfaces have huge number of points?
it's downsampling. Yeah.
Okay, but you don't do random ransack.
No, it first downsamples the data. It figures out to which level these downsample it, and then it makes an isosurface at that downsample level and combines them.
Okay, so so now these are registered. I don't know what was happening before, but you can see that that we're seeing the red and the green label overlaid on each other, and there's a pretty nice fit of the two now. So it produced a transform as output, and you can tell it to transform other layers. So that transform that was built, there may be other labels that you want to produce a transform version of. You can select them over here and then press the transform button. So it was just a sort of a quick and dirty way of registering a couple of data sets. Once you have produced some data that you want to save out to use in another application, if you right-click on any label, you can tell it to export it, and you can tell it what format you want to export things in. Again, we natively store most things in nerd format, but there is support for MATLAB and Ping and TIFF, and for those cases, it'll save it out as a series of images.
And for data layers, it actually does the diagram there.
Okay, so so here's the tooth data. You can export the data as a DICOM, right? Okay. So any questions about those tools that we've seen so far, or the layer manager? Other than Sarang, you guys are awfully quiet. All right. Okay, so so I'm going to show you some more of the tools and filters that we have built in. So So these are, a bunch of these are standard things. I need an ability to crop my data set. I need to be able to flip it and rotate it. These are all built-ins right here. The paintbrush tool is something that people use all the time. So for the paintbrush, you have the option of specifying a constraint. So I'm about to start painting, but I want my paint only to take if I'm on top of this other layer, right? So you can do positive constraints or negative constraints, so you don't go into regions that another layer is already in. You can control the radius. So the scroll wheel does that. So I'm going to pick this one as the one that I'm going to draw on. My scroll wheel is going to make my radius bigger or smaller. I'm only painting in 2D, so it's not a 3D brush. And painting happens with the left mouse and erasing happens with right mouse. This would be a great time to show you undo. So Apple Z is to undo things. And again, it has a pretty deep undo stack. So let's go in and make a couple of brush strokes. And then just for fun, I'm going to go in and do a erosion dilation. And after this, I'm going to show you the provenance of it, just so you can see what happened. We have two different versions of erosion dilation. And really, this is because the way that we do, it's because if you use a 1 pixel radius size kernel and you erode 5 iterations, you're going to get something that looks like a box as it builds out, right? And so we wanted the ability to make a stencil that was bigger, that looked like a sphere in 3D. And so the smooth one gives you things that look like spheres as their kernel, and the other one goes faster, but it doesn't look like a sphere. So you can run, so here we're going to run erosion dilation on this layer. You have the option of doing dilate and then erode, or just running dilate or just running erode, and you can do it yourself iteratively. So I'm going to dilate this green layer by 3 pixels and run it, and it's done, and it made a new layer. Anytime, or for a lot of these filters, there's a replace option. If replace is selected, it's going to replace that layer as you go. And you can use undo to get back, but yes?
So how do you do the undo in this case? Like, are you saving the volumes?
Yes, we are. And that how many of them we store was controlled in the preferences. So we said use, whatever, X amount of memory, and it's storing them. Oh, sorry. The question was, how are we doing this? Ross was asking, are we storing, actually saving these intermediate volumes? And I said, yes, we are. And the amount, the number of those, or how much space they get allocated to them was controlled over in the preferences. Okay, so now that we've done a few semi-interesting things, let's go look at the provenance layer associated with this. So provenance window is here. I have my active layer, the layer I care about, selected. I press the refresh button. Okay, so here's all of the things that we did to produce this layer that we're now looking at. So if I choose any of these, it tells me all of the parameters. And this is, somewhat human parsable, right? So these parameters all kind of make sense. But ultimately, this is Python code that we can rerun to recreate the layers, so we can load in sessions and reproduce things. So this is...
Okay, how would that work? I mean, can I specify what an initial target originally and rerun this? How would that work?
Yes. So you don't have the ability to edit this currently. I'll repeat the question. Ross was asking, how would that actually work? Could I go in and change any of these values here? And I was saying, no, you can't change them now. In a iteration down the road, we imagine letting people change them so that they can rerun to reproduce the results. But right now, it's just internally so that we can recreate them and so you can inspect them. Okay.
So you said this is Python code. What do you mean? I mean, Python coders do. What is, is Python code calling Python wrapped ITV filters, or what is it doing?
Yeah, so I think Jeroen is going to talk a little bit more about this action layer that sits in the middle and how these things get turned into. Right. But I will show you one thing that I had planned on showing. Ross was asking, how is this Python code? And I just said Jeroen will show it. So this is the controller window, which again has a bunch of things that are useful eventually as Python code, as Python snippets. But in this case, you actually can go in and run things. So in this command line, you can set things, you can say things like set state ID equal blah, 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 copy and paste it in there, and it will do something. So you can run a threshold tool by copying and pasting stuff in as opposed to clicking. And this kind of then links into the, oh, well, do I have to copy and paste into this window, or can something else be communicating with me? And
this makes references to things in the layer manager by name.
Yep, exactly. Yep, by name. I think over here it's showing it as $0 or something, right? So those are how they're referred to. Okay.
So all that is in your active memory.
Yep. This is all in active memory. So these are all your state variables in case it's useful to search in there. This is the event log of everything that's happened in the system since we started, and this has information about the undo redo buffer. So so a lot of things for you to poke around at and look at. Okay. So I will I'll just quickly kind of list some of the things that are in here. Maybe I should show, I'll show the speedline tool, because I don't know that people know what that one is, and then I'll show maybe a couple of others. So, so I'm going to hide these. We're going to go to pick our favorite tooth as a starting point, and I want to run the speedline tool. So, so speedline is a way of doing segmentation. You basically produce a polyline that grabs onto edges. You drop a few points along the way, and then it's latching on to the other points that minimize some energy functional on their way from the previous point to you. Okay, so as input, I'm going to tell it to use this tooth, and you need to give it, right. So, so this is the thing that bites me more frequently than anything else, so I'll point it out to you guys. So down here in red, the things that I invariably ignore, it's telling us that you need to do these things before you run this tool. You can press all the buttons you want. Nothing will happen until you do this. So you have to select a mask layer, which is, as I am done creating my outline of this thing, it wants to save out into a new mask layer. So, so we can do that. So if I click on this plus button down here, I tell it, great, I want a new layer, and it just made me a mask layer. Okay, so that mask layer is going to be the one that I use. My input data layer, this is where I specify my tooth. You create a speed image. So this is what your speed image looks like. It's basically kind of the strength of the edges. You can turn it off. And then you go into your image here. So I'm going to switch over to the coronal view in my big window and start outlining stuff. So you left click, and it's going to follow the contour for you all the way around. And when it thinks it knows a reasonable way to complete the loop, it will.
It's LiveWire, right?
Yes,
Okay.
but LiveWire is patented, so you have to call it something else if you want to use it.
Oh, okay, that's okay.
Yes, and I think instead of using, I think if this is the version that instead of using Dijkstra's, which is what Barrett did, it uses, I think, what was that? This is the ITK thing?
Yes.
So, yeah.
So, which you could arguably better than Dijkstra.
Yeah.
Maybe at this level, yeah.
So anyways, it does a reasonable job. And then at the end, you can say fill, and now I've created a layer. And then you can go to your next slice and move these control points if you need to, and once again, fill your layer. So that's how the speed line tool works.
You guys should talk to Paul Yuskowicz and get his ITK snap integrated.
Well, you mean the level set stuff?
Yeah,
Yeah.
the full level set.
Yeah. But I mean, we have all, it's all in ITK,
Yeah.
we built it here, so.
Yeah, so there is some level set here.
And I actually pay for the same thing over and over again. let's count that up.
No one has ever done that before. Yeah, so there is level set segmentation. I won't run it here, but this is showing the parameters. There's a bunch of other ones here.
So is this a 3D thing?
Yeah.
Have you tried, I mean, it works, it's debugged and so forth?
Sure.
I don't know, I mean, I've never seen it. Okay, this is good to know.
Well, here, let's try.
At one point we had one in the other Seg3D that wasn't working.
Yes, I remember that. There were some.
Okay. So
There were actually some parameters
I
that
wasn't
weren't.
trying to be,
No, I know.
just, you know.
There weren't.
It's the one from the previous version with a couple of bug fixes and gets it to work.
Does it show the real time? Does it show it running in the updates?
Yeah, it doesn't update every slide, every iteration, but you can tell it in advance and you can tell it yourself.
Okay.
But there's no stopping between. I remember we talked about this before.
There is stopping, but there's no impact if you tuning while it's running. So you just stop it and then change the count.
Okay, but you can continue it.
There was questions about the segmentation level set and whether it's the bugs have been fixed from the previous version. They have, and then there's a question of whether it can continue, whether you can tweak parameters while it's running, and you're said, well, you can stop it, tweak parameters, and continue from where you were. Okay, there were only a couple other things that I was going to show you today. One of them is that you can, as Jeroen just alluded to, you can actually cancel filters. So let's show a filter here. Curvature anisotropic diffusion, running on the tooth. We'll run it for 100 iterations. It's going to start running, and I see it's going to take a while, so I can cancel it. So they're cancelable insofar as ITK lets you cancel things, right? Because we're using ITK underneath for a lot of these algorithms. And here's what it looks like if you don't cancel it and just run it. It does do a nice job of smoothing out the data set. So here it is. Yeah, so as far as we know, these are all plugged in and working just fine. The distance map one sometimes is useful. So here's a distance map of from a label. So you have to tell it what you want to calculate your distance map from, and you run it. And then what we're looking at here is the distance from the outside of that label map. So this can be a good input to some of the calculator tools. So we have an arithmetic data filter where you can do things like just type arbitrary expressions down here that then get evaluated. So this value plus that value, and you can do Boolean operations as well. The last thing I was going to show, other than I mentioned the keyboard shortcuts, just to remind you, they're up here in the help window. And again, they are modal, so it's based on which tool is active down here. But these are good to remember. People oftentimes will run this in full screen mode, where you disconnect the left and right panels, and you just have your one big viewer window. When you do that, these things down here turn out to be really useful because you don't want to go over to your layer manager. So right now, what this is showing me is just my XYZ position of my mouse and what value is underlying. But if I press this, it toggles to allow me to select all of the parameters associated with my active tool. So I don't need to go over into my tool menu to specify those.
What do you mean by that? Can you show me?
Yeah, so I can choose what my inputs
Then
are.
what happens if you choose one of those?
Whoops.
Like, how are you going to edit it? Or is it allow you to see it, or can you edit those?
So this is this is which tool is active. So
Okay.
let's
Choose
move
that.
to this tool. Great.
Okay, now I got you.
And then here I'm setting what my active layer is. You're right, I can't set all of the parameters,
That's fine, yeah.
but a couple of things are exposed there, which is useful. So I'm going to load in a different data set here. So if I go to open a different project, so open project, I can either save it and it'll save all this information, or don't save it, and then I can choose this data set. So this is a knee vasculature data set. We'll see if my machine runs out of memory. So as it loads in the data set, it knows that it needs to recalculate some of the isosurfaces because the viewer had been saved with isosurfaces turned on. It hadn't actually saved the isosurfaces to disk, so it just recalculates them. And then you're seeing them there.
That's a feature of the way the session was saved, or what?
Yeah, the session only saves, the session doesn't save out like a VTK file with the geometry.
But
We
it
just
remembers
recalculate.
how the geometry was gotten.
Well, it's just an isosurface of a layer, right? So for these that I'm showing here, the
This is
bone and
kind
the,
of- Yeah, you're thinking of this as a, because this is only a viewer consideration.
yes,
So
right.
there's, in other words, there's no such thing as an isosurface of something that's not a layer.
Correct.
So you don't have to worry, that thing's always there.
Correct, and when we eventually support those, because people want to be able to import
Yeah.
masks, we'll have to save it out and load it back in. Okay, so choosing the vessels, I want to go in, I just want to show you the connected component filter. We'll see if this works. Again, it's kind of a big data set and I might run out of memory. So connected component is here. You choose what to use as your input, and I'm going to choose itself as the mask. So I just want to calculate all of the connected components of this particular label. So when it's done with this, it's going to give me each pixel, each voxel in my label will have an ID, so you could be part of component 1 or 2 or 3. And so if I go in and just look at those components, that's what I would see. But now I'm going to calculate something which is useful for this project I'm working on, which is I want to look at the connected component size, because what I want to do is throw away all of the little floaties. So there are these tiny little floating things that it thought were part of vessel. One way to get rid of those is to calculate connected components and then throw away those that are small. So connected components, load that in, run the filter, and now it's saving out a grayscale volume, where within this volume, each pixel knows the size of the connected component that it's attached to. And then if I go in and launch, say, a threshold tool, I can get rid of all of the small floating components. So great, I didn't run out of memory. That's good. Okay, so I'm going to choose this one. I'm going to bring up my threshold tool, and now I can tell it to use, if I want all those components that are, right now it has everything. And as I start to move up my threshold, I will see, let's see. Yeah. The bone is still on, thank you. Great. So here's all of the components. Again, these were the vessels. What you'll see is that as I make this bigger and bigger, certain vessels are starting to fall out, right? So these were attached to these weren't very big, these vessels here. So you can set, I only want to see the vessels that are at least connected to 10 other voxels, otherwise throw them away. And you can run this and it'll create a new mask layers output, and I could show the isosurface of it, and you would see that it had gotten rid of some of the floaty ones. Here, maybe I'll just do that. Here, we'll just save the very biggest components. And now if I isosurface this, and I turn on and off the red versus green in the volume view, hopefully you can see that the smaller components have fallen out. Okay, so I think that was all the things that that I wanted to show, just in terms of giving a quick user level overview of the software. Were there any other questions about how to use it or what you can or can't do with it? Yep.
So can you talk quickly over like what types of files you take as input and output? And
Yeah. So basically, it. I'm going to just pull up this last slide while we're talking through this. I'll just leave all of these future work things up. So it's relying on ITK for doing its input and output. So ITK has very nice support for loading in stacks of pings or stacks of TIFFs or DICOM files or nifty format, I don't know. They have support for all these different formats. And so because we're just piggybacking on them, we can import all of these imaging formats as well. So it should be pretty much anything that you would run into, but if there's formats that you run into that it can't, let us know. Yep.
There's also MATLAB and some other formats outside of ITK too.
Yeah, that's a good point. So we did build in our own support for other formats like MATLAB. We can read in and write out MATLAB formats for, I think for slices as well as for volumes, right?
Yes.
Yeah.
Now what about exporting those?
Yeah, so the write out part is for exporting those. So when I was in there and I right clicked for saving out, and MATLAB was one of the options, we do output MATLAB. It's using MATLAB version.
It's using the older MATLAB IO, so it's using version 7, not 7.3, but any MATLAB that you have will read the older versions.
Right, so we're not writing out the newest version of MATLAB, but everything should be able to read in the version that's a little bit older.
And then exporting other that's also supported through ITK?
Yes, Dana?
You know, one of the students here, I actually read the list of exactly that question, so I'll ask specifically, because it was limiting the ability to use it.
Great.
Yeah, I think the newest version can import any type of math file, but I think it cannot import or export the newest version of math file. I mean the version 7.3. Is it correct or?
That is correct. It's just exporting version 7.0, but you should be able to read that into MATLAB and save it as 7.3 if you need to, right?
Yes, yeah, that's right. I just wanted to make sure that it just exports the 7.0.
It does, yes, it exports 7.0. So I'll hand this over to you in a second. I just put up sort of a future work list. We have applied for NIH funding to do some of these things, especially support for bigger data sets, for more complex data sets. We'll be resubmitting that application in the next couple of weeks. We'll see how that goes. And the last thing to point out is that this project is in GForge here on the SCII servers. And if you find bugs or have minor feature requests or whatever, please put them in there. And then Liz and Isla will go through, and if there are things that they need to hand off to our team, so I should have introduced myself. So I'm the Chief Technology Officer at Numira Biosciences, which is over in Research Park. Jeroen is our software architect, and we have a small subcontract right now to support Seg3D. So if you have problems, if you see bugs, whatever, log them, and then these guys will forward them to us, and we will fix them as fast as we can.
or the mailing list, Seg3D, right, Seg3D at SCIInstitute.
Yeah, that would be fine too.
Okay. Yeah. You can send things to mailing lists, and somebody else will put it in as a Bugzilla bug. Yep. All right. That's all I had. So 10-minute break?
Yeah.
Okay. We'll take a 10-minute break, and then Jeroen will get up here.